For this problem, we're asked to determine which of the following are valid distribution functions, CDFs, and we're going to also justify our answer. So to do something like this, we have to look in the notes, and that's in the description below the like button. We're going to get a lot of information based off this, and CDFs are cumulative distribution function. So that's what our CDF is. If I bring the notes down really quick, it'll look something like this, where we have our CDF is the random variable x, and it's defined as the following. So it's going to look like this here. The main part of it is it's going to go and be something like this. But what we're focusing on is the graphing aspect of it. So how we would be able to write it like this, and then transform it into something like this. So this is more or less of what we're going to be focusing on. You can just pause it and take a look and read it here. But we'll move this out of the way, and we'll actually do our current problem. So for our current problem, we have something that looks like this. Let's start off with A. And in A, we see that there's two kind of things we have to look out for. We have to see when x is less than 0, we have to make sure it's 0. And then when it's greater than or equal to 0, it's going to, well, when x is a number like this, it would just be greater than or equal to 0. So that's pretty simple. If we draw a graph out like this, we can get ahead and start drawing this out. So it's pretty obvious that if we use this right here, if x is a number less than 0, it's going to go that way. We can try this first off by saying, well, let's say that our f of x is like a -3, and this -3 is going to equal to 1 minus e, and then this is raised to, the negatives cancel out, this is going to be 3/2, right? And if we plug this into a calculator, this is going to give us a negative number. And we can keep plugging this into a calculator, and I believe it's going to be around 1 or something like that. But we can just zero this out here. It's going to be 0, and we'll do this in red. So for this, when x is less than 0, it's going to be 0 like this. Now, looking at the notes again, we're going to have something like the following. This is for our CDF. So for CDF, we are going to have the probability of x being less than 0. This is going to be equal to p, where x is equal to 0, and we know that this is equal to 0. So this is going to just be like our baseline right here. Now, what happens when we move on to the next thing, where, like, let's say f of x is 1. Well, this is going to be equal to the probability of x has to be less than or equal to 1 itself, right? And so this means that we're going to have the probability of x to 0, everything before it really, plus the probability of x, and then we have it as 1 right here. Now, when we have something like this, we can just plug in our values, right? We know that this is going to be 0 plus probability with our 1 here. Well, we just really plug it 1 into this, right? So we essentially have a 1 minus 1 over e to the 1/2 like this. We have to flip the part right here because of so we're changing where the sign's a negative here. So to change the sign, we flip it to the bottom. And if we do something like this, we basically have a small number over a big number. So basically like 1 over infinity, which is going to make this overall really small number. And what we do every single time, if you pay attention, is this is going to be like 2, right? But it's going to become a -1. So this is like 1 minus 1 over e. And essentially every time you do this, we are going to get a smaller and smaller number here. So this, every single time, and we can keep doing this, right? Like if we do f of x for 2, it's going to be equal to the probability of x has to be less than or equal to 2, and this is equal to, and then we would add these, but really it would just be like the probability of x less than or equal to 1, which would be what we have here, this total right here, plus the probability of 2, like this. So when we have something like this, we just combine the previous result, right? And this is going to be, it's going to get very, very close to 1 if we were to keep doing this. So this would just step up to 1, and then we would just keep going up from here. So every time that this goes up, if 1 is like right here, it would just be going up like this until it gets to our 1. So each of these increments are going to be kind of small decimal numbers based off what we have here and then here. You can think of this as like a summation because this x has to be less than equal to 1, so it basically adds whatever we have previously. There's more about this in the notes, but this is how we would solve for our part A. Now for part B, it's a little bit tricky. You can use the exact same method. You can also plug it into a graphing calculator as well to get a very similar result. This is kind of the result for part A. And then for part B, it would look something like this. Now this is really wavy, and we can see from the instructions here, if x is less than 0, it should be a 0, right? And while this is not true, it doesn't even satisfy the part where it goes to 1, so it's not a valid solution. But this is not valid because it doesn't go to 0, and then when x is greater than or equal to 2, which would be like right here, it doesn't go to 1, right? It just keeps going like this. It does satisfy the second part though, where when x is between 0 and 2, right here, it would be something like this, I believe. But other than that, it doesn't really work out, so it's not a valid solution. And then for part C, this one's a little bit interesting as well. So if we have this x over a, this should be x over a, and then we have all this inside of here where u of x is the unit step function. What we can basically see is that this is not valid because, and this is because of just a CDF rule, that this has to be going to 1, right? So as it goes, it needs to go, as it goes from f of x to like infinity, it has to go to 1, right? And this, if we put infinity in for here and in for here, it's not going to go to 1, it's going to go to infinity. So this one as well is not a valid step, is not a valid function. So neither of these are valid. Continuing on from part A though, I kind of made this mistake. We can say that our result is g of x, and if we have it at negative infinity, we can see it's going to 0 like this. And for our g of x going to infinity, we can see that it is going to 1 like right here. So that's how we go about looking at this problem.